Welcome to the Digital Revolution with Jim Kunkel. In this bonus episode titled AI's Massive Thirst for Energy, we'll get into one of the most pressing challenges facing the tech sector today, the enormous energy demands of artificial intelligence. As AI continues to revolutionize industries and transform our daily lives, its energy consumption is skyrocketing. From training complex machine learning models to powering vast data centers, the thirst for energy is becoming a critical issue. Let's also explore the environmental impact of AI's energy use, the innovative solutions being developed to mitigate this, and what the future holds for sustainable AI. Join me as we discuss the scale of AI's energy consumption, understanding the magnitude of energy required for AI operations, factors contributing to high energy usage, energy requirements for cooling and maintaining data centers, environmental implications, how AI's energy use affects our planet, and what can be done to reduce its carbon footprint. Innovative solutions, cutting-edge technologies and strategies aimed at making AI more energy efficient. Future outlook and prospects. What lies ahead for AI and energy sustainability that feeds AI? Whether you're an intelligent technology enthusiast, an industry professional, or simply curious about the intersection of AI and its energy sustainability, this episode is packed with AI industry insights and my opinions that you won't want to miss. Tune in and join the conversation by texting or emailing the podcast on how we can balance AI's incredible potential with the need for a sustainable future. Let's get this conversation started. Understanding the energy demands of AI is crucial for several reasons. First is the environmental impact. AI systems, especially large-scale models, require significant computational power, which translates to high energy consumption. This can lead to increased carbon emissions if the energy comes from non-renewable sources. By understanding these demands, we can work towards more sustainable AI practices. Second is its economic considerations. Energy costs are a major factor in the overall expense of running AI systems. For businesses, optimizing energy use can lead to substantial cost savings, making AI projects more economically viable. This next reason is critical. It's infrastructure planning. As AI continues to grow, so does the need for robust infrastructure to support it. Understanding energy requirements helps in planning and developing data centers and other facilities that can handle these demands efficiently. Consideration must be made related to technological innovation. Awareness of AI's energy consumption drives innovation in creating more energy-efficient algorithms and hardware. This can lead to advancements that not only reduce energy use, but also improve the performance and scalability of AI systems. As the AI economy rolls out, there will be growing regulatory compliance. Governments and regulatory bodies are increasingly focusing on the environmental impact of technology. Understanding energy demands helps organizations comply with regulations and avoid potential penalties. And finally, sustainability goals. Many businesses and organizations have set ambitious sustainability goals. By understanding and managing AI's energy consumption, they can align their technological advancements with these goals, contributing to a greener future. In essence, comprehending AI's energy demands is key to balancing technological progress with environmental responsibility and economic efficiency. AI's energy consumption is a growing concern, with several key AI industry statistics highlighting its impact. Global energy usage in 2022, AI contributed to approximately 2% of global energy usage, comparable to the energy consumption of a small country. By 2026, it's projected that AI could use as much electricity as Japan. Data centers' AI's energy demands are a significant factor in the projected 80% rise in U.S. data center energy consumption by 2030. Training and inference. The energy required for AI tasks is accelerating, with an annual growth rate between 26% and 36%. Training AI models accounts for about 20% of the energy use, while inference, meaning applying the trained models, takes up the remaining 80%. Future projections. By 2027, AI servers could potentially use between 85 and 135 terawatt hours annually, which would be around 0.5% of the world's yearly electricity consumption, equivalent to the Netherlands' annual energy consumption. And when it comes to computational power, the computational power required for AI is doubling roughly every 100 days. This rapid increase underscores the need for more energy-efficient AI technologies. These statistics underscore the importance of developing sustainable AI practices to mitigate environmental impacts while continuing to harness AI's transformative potential. Understand there are several factors contribute to the high energy usage of AI data centers. First is the complexity of AI models. Training. Large AI models such as deep learning networks require substantial computational power. These models often involve billions of parameters, necessitating extensive processing capabilities. Now mix in high data volumes. AI systems process vast amounts of data. The storage, retrieval, and processing of this data require significant energy, especially in large-scale operations. Hardware requirements. AI tasks often rely on specialized hardware like graphics processing units and tensor processing units, which consume more power than traditional CPUs. These components are essential for handling the parallel processing demands of AI workloads. Also needed are supercritical cooling systems. Data centers generate a lot of heat due to the intensive computational activities. Effective cooling systems are necessary to maintain optimal operating temperatures, and these systems themselves consume a considerable amount of energy. On top of everything that I mentioned, centers require 24/7. Operation AI data centers often operate continuously to meet the demands of real-time data processing and service availability. This constant operation leads to higher energy consumption compared to systems that can afford downtime. Also, redundancy and reliability. To ensure high availability and reliability, data centers often have redundant systems and backup power supplies. While these measures are crucial for uninterrupted service, they also add to the overall energy consumption. Network infrastructure. The infrastructure required to support data transfer between data centers and end users, including routers, switches, and other networking equipment, also contributes to the energy footprint. And currently, the AI industry suffers from inefficiencies in algorithms. Not all AI algorithms are optimized for energy efficiency. Inefficient algorithms can lead to unnecessary computations, further increasing energy usage. Addressing these factors involves a combination of technological innovation, improved data center design, and the adoption of more energy-efficient practices and hardware. Several innovations and solutions are being developed to address the high energy demands of AI data centers, with a strong push towards creating greener, more sustainable operations. Energy-efficient hardware. Advances in hardware design, such as more efficient GPUs and TPUs, are reducing the energy required for AI computations. Companies are also developing specialized AI chips that are optimized for energy efficiency. Renewable energy sources. Many data centers are transitioning to renewable energy sources like solar, wind, and hydroelectric power. This shift not only reduces carbon emissions, but also helps stabilize energy costs. Advanced cooling techniques. Innovations in cooling technology, such as liquid cooling and immersion cooling, are significantly reducing the energy needed to keep data centers at optimal temperatures. These methods are more efficient than traditional air cooling systems. AI for energy management. AI itself is being used to optimize energy consumption within data centers. Machine learning algorithms can predict and manage energy use, dynamically adjusting power distribution to minimize waste. Modular data centers. Modular data centers, which can be quickly deployed and scaled, are designed to be more energy efficient. They often incorporate advanced cooling and power management systems from the outset. Edge computing. By processing data closer to where it is generated, at the edge of the network, edge computing reduces the need to transfer large amounts of data to centralized data centers, thereby saving energy. Energy storage solutions. Integrating advanced energy storage solutions, such as batteries and other forms of energy storage, helps manage energy use more effectively and ensures a steady supply of renewable energy. Green building certifications. Data centers are increasingly seeking certifications like LEED, which stands for Leadership in Energy and Environmental Design, to ensure they meet high standards for energy efficiency and environmental responsibility. Virtualization and containerization. These technologies allow for more efficient use of hardware resources by running multiple virtual machines or containers on a single physical server, reducing the overall energy footprint. And green planning such as carbon offsetting. Some companies are investing in carbon offset projects to compensate for their energy use. This includes reforestation projects, renewable energy investments, and other initiatives that reduce or capture carbon emissions. By combining these innovations and solutions, the tech industry is making significant strides towards creating more sustainable AI data centers, balancing the need for computational power with environmental responsibility. Now let's wrap up this episode and talk about the future outlook of energy consumption of AI data centers. The future outlook for energy consumption of AI data centers is both challenging and promising, with several reported key AI industry trends and projections, such as significant increase in demand. AI's energy consumption is expected to continue rising sharply. By 2030, AI could drive a 160% increase in data center power demand, adding approximately 200 terawatt hours per year. This surge is driven by the growing complexity and scale of AI models, which require substantial computational power. Integration of renewable energy. To mitigate the environmental impact, there is a strong push towards integrating renewable energy sources. Many data centers are transitioning to solar, wind, and hydroelectric power, aiming to reduce their carbon footprint and stabilize energy costs. Technological innovations. Advances in energy-efficient hardware, such as specialized AI chips and improved cooling technologies, are expected to play a crucial role in managing energy consumption. Liquid cooling and immersion cooling, for example, are more efficient than traditional air cooling systems. AI-driven energy management. AI itself is being leveraged to optimize energy use within data centers. Machine learning algorithms can predict and manage energy consumption, dynamically adjusting power distribution to minimize waste. Regulatory and policy support. Governments and regulatory bodies are increasingly focusing on the environmental impact of data centers. Initiatives like the U.S. Department of Energy's Roadmap for AI and Data Center Infrastructure aims to address the growing energy demands while maintaining grid reliability and sustainability. Sustainable practices. The industry is adopting more sustainable practices, such as modular data centers, edge computing, and virtualization, which help reduce the overall energy footprint. Community and environmental concerns. As data centers expand, they face challenges related to local electricity shortages and community environmental concerns. Addressing these issues will require collaboration between tech companies, energy providers, and policymakers. Overall, while the energy demands of AI data centers are expected to grow significantly, ongoing innovations and a strong focus on sustainability offer promising solutions to balance technological advancement with environmental responsibility. Thank you for joining in on this insightful journey into AI's massive thirst for energy. As we've explored, the energy demands of AI are immense and growing, posing significant challenges but also driving incredible innovations. I hope this episode has shed light on the critical importance of understanding and addressing AI's energy consumption. Thank you for tuning in to this bonus episode of The Digital Revolution with Jim Kunkel. Your support and enthusiasm makes this journey so rewarding. We appreciate every listen, share, and piece of feedback from our incredible community of followers and subscribers. As we continue to explore the ever-evolving landscape of digital transformation and intelligent technologies, we invite you to stay connected and engaged. On your way out, don't miss a message about joining the Buzzsprout platform, where you can start your own podcasting adventure and share your voice with the world. Until next time, keep innovating and stay curious about digital transformation. Hey there, podcasters, or those of you listening to this episode who has an interest in starting your own podcast. Well, I've got an exciting announcement for all of you who are passionate about podcasting or looking to launch a podcast. Podcasters, are you using Buzzsprout to host your podcast? If not, you're missing out. Buzzsprout is the ultimate platform for podcasters, offering top-notch hosting, distribution, and analytics. And for those looking to start a podcast, Buzzsprout is the perfect podcast solution for beginners. No matter where you are with your podcast, I've got some great news. Introducing Buzzsprout's Refer a Friend program. So my friends, check out and sign up with Buzzsprout, and both of us get rewarded with a referral credit. It's a win-win situation, but that's not all. Buzzsprout's referral program isn't just about credits. It's about building a community of passionate podcasters who support each other. So, what are you waiting for? You'll find the referral link in this episode's description, then head over to Buzzsprout and sign up. Let's grow together and revolutionize the podcasting universe.